If you want to build a house, you don't just throw bricks at a pile and hope they stick. You need a way to snap them together, precisely where you want them. In the world of organic chemistry, building large carbon chains used to be surprisingly difficult. But notice what happens when we use the Corey-House synthesis. It's essentially the Lego set of molecular construction. To understand why this is so special, let's first look at the problem chemists were facing. For a long time, we used Wurtz coupling to join carbon chains, but it was messy. If you tried to combine two different carbon groups, you'd end up with a random mixture of products. It was like trying to glue two specific Lego bricks together by shaking them in a bucket with 100 others. The Corey-House synthesis changed that by introducing a specialized mediator molecule, the organocopper reagent, also known as a Gilman reagent. Let's visualize the three-step process. First, we start with an alkyl halide. Imagine a simple carbon chain with a halogen atom, like bromine, hanging off the end. We treat this with lithium metal. As you can see here, the lithium replaces the bromine, giving us an alkyl lithium compound. This molecule is powerful, but it's a bit too aggressive for precise building. That brings us to step 2, the secret sauce. We add copper-1 iodide. Watch how the lithium atoms swap places with the copper. We end up with this unique structure, a copper atom sandwiched between two carbon chains. This is our Gilman reagent. Now, here is the key insight. Even though there are two carbon chains attached to the copper, only one of them is going to do the work. The copper acts like a steady hand, holding the carbon group and waiting for the right moment to strike. In the final step, we introduce a second, different alkyl halide. Let's call this our target piece. Because the Gilman reagent is less reactive than other organometallics, it doesn't just explode or cause side reactions. Instead, it performs a precise surgical strike. One of the carbon chains from our copper reagent breaks away and forms a perfect single bond with the new carbon chain. We've successfully fused two different carbon groups into one long, continuous chain. No mess, no random mixtures, just a clean connection. But wait, why does this matter? Well, the beauty of the Corey-House synthesis is its versatility. Unlike many other reactions, it works even if our carbon chains are bulky or have specific shapes. It allows us to build complex, branched molecules that are vital for medicines and advanced materials. So, the next time you see a complex molecular structure, remember that it wasn't built by accident. It was built piece by piece, using molecular tools like the Corey-House synthesis to turn the chaos of chemistry into the precision of architecture. It reminds us that in chemistry, as in life, sometimes you need a steady hand, or a copper atom, to bring two separate worlds together.